Pick up any analyst report about cloud computing, and you'll find security often mentioned as the biggest barrier to enterprises running sensitive applications in the cloud. By hosting content off-site on a service provider's premise, and what's more on multi-tenant architectures, which has been made possible by virtualization, data is simply exposed to more security threats. So while security needs to be addressed holistically, in other words, as an end-to-end solution, I'm going to focus on one aspect of securing the cloud, and that's the impact of server virtualization on security. Virtualization is very widely adopted in data centers nowadays, and it's what enables cost-effective multi-tenancy with more optimal use of compute resource. But it does introduce a completely new set of security challenges. For starters, you have the concept of network blind spots. Your traditional network security appliances are blind to any communications between virtual machines or VMs within a single host. And this obviously opens up a loophole for all sorts of security attacks, one example being inter-VM attacks. You only need an attacker to compromise one virtual machine and then leverage that VM as a springboard to attack all of the other VMs on the same host. And the more VMs you have, the more effective the attack. So now the same attacker can also use that compromised VM to launch an attack on the hypervisor itself, and this is a technique known as hyperjacking. Since the hypervisor is the most critical piece of software that controls all of the VMs running on a single piece of hardware, it's a very natural attack target. You still need your existing network appliances to provide defense in depth, but to protect against attacks between VMs, I need those same security capabilities like firewalling and intrusion detection, but now at the VM level, so that we can monitor and control activity between VMs and also from VMs to the hypervisor. And there are several ways of doing this, but the most effective and performance solution is to run virtual gateway software within the hypervisor kernel itself. And performance translates into higher utilization and higher cost savings. A risk with any virtualized device is the ability for one badly behaving user or application to impact other users on the same system. And it may have nothing to do with a deliberate attack. It may just be the result of a particularly resource-hungry app, which consumes so much CPU that other apps running on the same system are starved of the resource that they need. And this may just happen to be a particularly critical application. Now, this isn't something you solve with a security appliance. You have to make sure that your service policies define a minimum amount of resource for critical apps. A typical multi-tenant cloud must support VMs with different security or trust levels, depending how sensitive or critical the data is. One way of dealing with this is to separate different trust levels physically, meaning you only support one trust level per physical host. But this is where you can really have a negative impact on the profitability of the cloud, since you get your biggest cost savings through better utilization of servers. And you may want to move workloads between physical hosts to achieve that. If you segregate traffic according to trust levels, the chances are you're going to achieve much lower utilization, and that has a significant impact on costs and margins. The goal is to be able to have mixed trust levels on a single physical host and up the utilization of that compute resource. And again, we find ourselves needing interzone capabilities at the VM level. So this again means having firewalling, intrusion detection, etc. between VMs. A cloud wouldn't be a cloud if users weren't able to provision their own services via a portal, and this can compound some of the problems of virtualization. The majority of virtualization solutions on the market are very rich in functionality and support the ability to revert to previous instances or images. And this is an important capability because there may be very valid reasons to want to roll back to a stable image or recover lost data. VMs can also be paused and restarted. They can be cloned and also seamlessly moved between physical servers. Now, unfortunately, all of this flexibility makes it all too simple to introduce vulnerabilities or configuration errors. For example, rolling back to a previous image that hasn't been patched with the latest security update, and I have a vulnerable VM that can be exploited or compromised. And as I said earlier, this gives attackers a springboard to do some damage to other VMs and the hypervisor, particularly if there aren't the right safeguards in place. So when you're choosing a VM-level security gateway, it's important to check that it offers safeguards against rolling VMs back to images that don't meet the requirements of the enterprise security policy. So as we can see, there are several new security challenges posed by cloud because of multi-tenancy, virtualization, and customer self-provisioning. But they should only be considered as hurdles, not barriers to deployment, as many of the issues I've discussed have already been solved with network appliances and software that sits in the hypervisor. Be safe, be secure.